Hi, my name is Steve Kurtz, and I'm a Corporate Vice President at Exponent. Exponent is a publicly traded scientific and engineering consulting company. We've been working with StelKast now for over 2 years to develop the EXP liner. The EXP liner uses vitamin E technology to stabilize a highly cross-linked polyethylene material. We've used vitamin E as the primary means for stabilizing the polyethylene against in vivo oxidation as well as oxidation on the shelf. Here's an example of what an oxidized polyethylene acetabular liner will look like after maybe 5 to 10 years in vivo. As you can see, the rim is severely oxidized. This happens when the polyethylene is exposed to the oxidizing environment in the body. There are two ways of introducing vitamin E to polyethylene. One way is to dope vitamin E into the material after it's been irradiated. Second way is to introduce vitamin E to the resin powder and consolidate the material afterwards. We prefer blending because that way the vitamin E can protect the polyethylene throughout the entire manufacturing process rather than just being added at the end. An advantage of vitamin E is that you don't need to anneal or remelt. These first-generation technologies alter the crystalline microstructure of polyethylene. By using vitamin E, you can avoid this. Historically, ultra-high molecular weight polyethylene has been susceptible to both shelf and in vivo oxidation. The pathway for oxidation begins with high-energy radiation of the polyethylene during sterilization or cross-linking. It can occur during processing as well as during sterilization. High-energy radiation introduces free radicals into polyethylene, which are then available to react with oxygen in the environment either on the shelf before implantation or from the tissue surrounding the implant after implantation. Oxidation results in embrittlement of the polyethylene as well as a loss in mechanical properties such as component fracture, wear, and fatigue. There are three key features of the EXP liner technology that I'm now going to go through. The first of these is oxidative stability. We've looked at oxidative stability two ways. First, we put polyethylene liners that were blended with vitamin E using the EXP technology into an accelerated aging bomb, and we accelerated aged them for a month. When we looked at the EXP liners and compared them with the undoped materials or the unblended materials, we found that the vitamin E containing materials had negligible oxidation, whereas the conventional polyethylenes oxidized. We also did a second test to evaluate the oxidative stability by looking at material that had been through a very long, 5 million cycle wear test. So again, after 5 million cycles of wear testing, we looked at the level of oxidation in the materials, and we found that the vitamin E containing materials had negligible oxidation at the bearing surface. So again, this gives us some degree of confidence that the material won't oxidize in vivo. Now, in addition to being stabilized from oxidation, it's really important that the liner preserve its mechanical properties. So what we've done is we've looked at not just oxidation, but also mechanical properties using the small punch tests. So after accelerated aging, we took the liners and we made miniature specimens from them and we mechanically tested them. When we looked at the ultimate strength of the polyethylene after accelerated aging, we found that the vitamin E liners had preserved their mechanical properties. A third area that we did a lot of research in was biocompatibility of the EXP liners. We did this two ways. One was by looking at elution, where we tried to immerse the vitamin E containing material, the EXP liners, in both a polar and a non-polar solvent. And we looked to see if any vitamin E would elute out or any transformation products of the vitamin E would elute out. We didn't find any. The other series of tests that we did were all the kind of standard ISO 10993 tests. So we looked at the genotoxicity, the cytotoxicity, and the sensitization and the irritation tests for 10993. And the EXP liner passed all those tests. So in summary, the EXP liner is oxidatively stable, has preserved mechanical properties, and is also biocompatible.